Components of Kubernetes. Kubernetes is an open-source container orchestration platform that automates the deployment, scaling, and management of containerized applications. It provides a reliable and scalable infrastructure for running containerized workloads across multiple nodes in a cluster. In this part of the course, we explore the various components that make up the Kubernetes ecosystem. The master node is the control plane of the Kubernetes cluster. It coordinates and manages the overall cluster state, schedules applications onto nodes, and monitors their health. The key components of the master node are etcd, a distributed key value store that stores the cluster's configuration data and the state of all the resources in the cluster. API server exposes the Kubernetes API, which allows clients to interact with the cluster. It handles authentication, authorization, and validation of the API requests. Scheduler assigns pods to nodes based on resource requirements, constraints, and other policies. Controller manager runs various controllers that continuously monitor the cluster's desired state and takes action to bring it closer to the actual state. Additional components of the master node are kubelet, which is primary agent on each node that communicates with the master node and is responsible for starting, stopping, and monitoring pods. Container runtime, which manages execution of containers. It implements the container runtime interface, CRI. Examples include Docker, Containered, and Cryo. Kube proxy, which acts as network proxy and load balancer. It maintains network rules and forwards traffic to the appropriate containers. Controllers are integral to the self-healing capabilities of Kubernetes. They continuously monitor the cluster and take action to ensure that the desired state is maintained. Some key controllers include replica set controller, ensures the desired number of replicas of a pod are running and replaces old or failed pods. Deployment controller manages the rollout and rollback of application updates, allowing you to seamlessly deploy new versions of your applications. Stateful set controller manages the deployment and scaling of stateful applications, providing guarantees for ordering and stable network identities. A service is an abstraction that defines a logical set of pods and a policy by which to access them. It provides a stable network endpoint for accessing the pods, even as they may be dynamically created or replaced. Kubernetes supports different types of services, including Cluster EAP exposes the service only within the cluster. It is accessible through an internal IP address. Node port exposes the service on a port across all nodes in the cluster. It allows external access to the service using the node's IP address. Load balancer automatically provisions an external load balancer to distribute traffic to the service. It is typically used in cloud environments. Volumes in Kubernetes provide persistent storage for containers. They allow data to persist beyond the lifecycle of individual pods. Kubernetes offers various volume types such as empty-dir, a temporary volume that is created when a pod is assigned to a node and deleted when the pod is terminated. Persistent volume represents a piece of network-attached storage, NAS, or block storage allocated by an administrator. Config map and secret, special types of volumes that allow you to inject configuration data or sensitive information into pods. One of the most important patterns that are used in Kubernetes is the operator pattern, which is a fundamental extension in Kubernetes. It enables custom automation for application management and automation of complex operational tasks beyond what vanilla Kubernetes provides. Operators encapsulate domain-specific knowledge, which allows for automated provisioning, scaling, updates, and self-healing. This reduces manual effort and operational complexity when managing stateful or complex applications. In practice, an operator is a software component running inside your cluster. Operators use configuration files called custom resource definitions, TIEs, to define the types of resources they manage and how users can customize those resources. However, the actual operator consists of program code, often packaged as a container, that watches these custom resources and acts upon changes towards automating tasks such as deployments, upgrades, backups, and resource scaling. A typical example where the operator pattern is highly useful is when there is a need to manage stateful databases like PostgreSQL in Kubernetes. A PostgreSQL operator can automate the deployment, scaling, backups, failover, and upgrades of database clusters, which are operations that would otherwise require manual intervention and deep expertise. This simplifies lifecycle management and ensures best practices and consistency, even as environments scale or requirements evolve. Another popular example is the Prometheus operator, which automatically manages the setup, configuration, and monitoring of Prometheus instances in a Kubernetes cluster. It handles updates and recovery tasks so that users don't have to perform them manually. These operators encapsulate complex operational logic and help making application management more robust and less error-prone. These are the essential components that make up a Kubernetes cluster. The various components, including master node components, controllers, service types, and volumes, play essential roles in the Kubernetes ecosystem. Understanding their roles and interactions is crucial for effectively deploying and managing containerized applications in a Kubernetes environment.